Hello everyone. Well, first chance to make a video in a long time, so I'm cracking on. This is the valve block, the safety relief valve block that goes on top here. I've just finished off the actual regulator with its, and I've ordered some, see, open and close, I've ordered some graphite packing for this side. Yeah, so I'm just making the valve block that goes on, I'll silver solder on here and then carry on making the valves once I work out what spring I need. Alright, so here I am testing one of the pressure relief valves. This will be, I don't know if it will be the higher or lower pressure one, but I've made two of these. At the minute, I'm sealing nicely at 90. So the compressor's getting a hell of a workout at the minute. What I've been doing is I've been just trying to measure the hysteresis on the valves. That's how much when it goes off, and then how much it goes down to when it seals again. I've had terrible trouble with this one. If we have a look. So that is a hysteresis of about, when will it go off? It's about 30 psi. So that's on air. What I'm going to do is I'm going to leave it at that, and then I'll adjust them finally on steam when I get there. It may just need a few thou off the actual valve inside there, but I'll take them apart and show you how I've done them. So here's the internals of one of the valves. I have tested this already. This has a hysteresis of around 20, 25 psi as well, which actually works out pretty much exactly what I worked out. Spring I bought from Lee Springs, and I've designed them as not like the drawings. I fancied more of an industrial look, modern industrial safety valve that you see in many applications. And then on the discharge I've got one of this that I'm going to have them both feeding into this common discharge. Whether this works, whether it causes too much back pressure, is yet to be seen. Like I say, so on steam this will all be tested. But there's the internals. Actually was doing some research, and I found a bit of research paper saying the materials used for like safety valve seats and stuff, often for steam, is a stainless steel valve to a stainless steel seat. What I tried initially was these little bronze, you can't even see it, these little bronze cups that went on the end of the valve stem. Oh, right, like so, and then sealed against the face, direct face, like they do in large pressure relief valves. However, when I managed to get them to seal really nicely. I lapped them in, and using the old suck test on the tongue, they sealed really nice. But unfortunately, when they actually went in the chamber, it seems like the pressure was vibrating them a little bit. They had no way to kind of seat themselves properly, so they were just leaking. So I've gone over to the Tri design with a 45-degree valve seat. and I've lapped these in, so they're a nice fit now, and the old suction test on the tongue's good. So a quick word on the maths that I used to work out what spring I need. It ended up being 3.11 newtons per millimetre of spring force. You can look on Lee Springs and work out, you know, how much you want per millimetre, and that's the spring that come out, which is that one there, or it was pretty damn close. I think it was 3.14 newtons per millimetre, so for my purposes that was pretty much perfect. And also worked out how much preload I want on there. If anyone's interested, I'll put this underneath the video and explain each step. Side by side, you can actually see how much I had to change on the second valve to get it to actually seat and reset. The weird thing was, I was using this design, this stainless steel on stainless steel seat, and it was sealing to the suck test. But as soon as I put it in there, with the spring forcing down on it, it just did not want it. It would leak instantly, straight away. So I had to machine the seat in bronze. This is stainless steel. You can actually kind of see, maybe if it would focus, how it's sealing nicely all the way around. And yeah, I had to obviously drill down so that and then silver solder a extra piece into the valve stem. Obviously in this one you can see it just sits straight on top and pushes down, but that one works fine. If I have problems with this in the future, I might remachine it to this better design. But for now, this seems to work fine. And yeah, this one works good too. So I'll have two different designs of valve, but at least I know if I have problems with this in the future, I can upgrade it to this one. So I have the second valve with the stainless steel seat installed. Let's just test the hysteresis on this. Yeah, so that was from 110 down to 90, so 20 psi. Yeah, so pretty much what I calculated, which is nice to see the maths all lines up, on these little safety relief valves. Even, yeah, pressure area, pressure area and spring rate all comes together nicely. Also, as you can see, I've installed the regulator now, and I've packed the gland. Just got these little like dome locking nuts on, which I thought was a nice feature. I'll show you inside in a second, but as you can hear, I've got nearly 100 on there, and no leaks at all. I've got the drain cocks out in case it was going to leak, so that the engine wouldn't turn over while I was trying to test it. But yeah, it's a good little double test there.